So maybe you can give us a quick introduction to what Bayesian statistics is, and then also tell us about this library formerly known as PyMC3, now known as PyMC.
Sure. So yeah, Bayesian statistics or Bayesian modeling for me is a fundamentally different approach to doing data science, specifically when you compare it to things like machine learning. So machine learning for me is like very much, well, you have sort of one tool and that you just pump in data and outcomes predictions. And often that's why it's called black box, because the thing that gets trained, you don't really know what's going on underneath, right? So the predictions come out and oftentimes they're quite good if you like did everything correctly. Uh, but that if you can't really inquire the model and understand why it came up with this, it's very hard to really gain insight about your data and learn yourself about the type of things that are going on. And that for me just disqualifies it for a lot of applied business problems, which is what I care about. Because there, when you tell your manager, like, oh, like we should be increasing our media spend by 100%. Uh, I can't tell you why, but like the black box said we should. Like
Right.
that often doesn't fly as well. So Bayesian modeling instead is like what I like to call the Lego approach, where you build a particular model for a particular purpose. So you customize it for this thing, and it's then like hand tailored for this data science problem that you're working with. Um, just like with Lego, right? So you like buy the spaceship thing, and you can build the spaceship with it, but you can also build a robot or whatever it is that you really want.
Mhm.
And the building blocks that you're using to build this up are probability distributions. So fundamentally, that is sort of what we're doing, and we're plugging things into each other and basically mapping the business problem or the research problem, the process of how the data was generated. We map that into a model, and then this model essentially is capable of generating new data that we might observe. And once you have that, right, so you have the forward model, you can then say, okay, well, now that I know how, now that I have modeled the data generating process, how can I invert that to say, okay, given the data I actually have observed, how can I reason my way backwards now to the hidden causes that I actually care about? Like, for example, how effective was that media channel in driving sales? Which is a thing that I can't observe, right? I can only observe the downstream effects. So Bayesian modeling is just really, really good at that. And it's like one thing that is often also mentioned as like a key benefit is that it is very principled about how uncertainty is quantified. So again, with machine learning, usually you get like the best fitting solution and the most likely answer to your solution. And I mean, that's cool in some cases, but often, like say you're in a medical situation, probably you don't just want to say like, yes, that is cancer or not cancer. You want to have some probability, you want to have some uncertainty, right? Like if it's based on like very little data, probably you're just going to say, well, I can't say, right? I don't have an answer for this, which is like a perfectly reasonable thing to do in the absence of data. Um, and Bayesian modeling allows you to express these things because not only are the models built out of these probability distributions, but the outputs of it, the parameter estimates, are also
Right.
probability distributions.
Right.
So that is like the core principle is we are quantifying uncertainty with probabilities. And that's, for me, the most intuitive way of going about doing that. Um, but really, the other thing that I think for me makes it so powerful is uh, when you actually go about doing that, right? So far, what I describe is just the theory, and that is like hundreds of years old. Um, but it never has been really possible to use this like beautiful theory in practice, just because the math is just really, really gnarly when you go about doing it and like building your own model, right? So now with estimation algorithms, so we can solve it analytically, but we can estimate the solution. We can estimate these probability distributions that we're interested in, that are our answers. using a very general class of algorithms called Markov chain Monte Carlo.
Mm-hmm.
And those then allow you to automate the fitting process, the estimation process, which is one piece of the puzzle. But the other piece of the puzzle is, well, how do we even build the models, right? So I just said that the core strength of this is that we can build customized models for a particular data science problem. And that's where the power of probabilistic programming comes in, which is packages like PyMC or Stan or NumPyro. And they allow you to write in computer code, in the case of PyMC, it's Python code, a statistical model where you say, well, I have a variable, for example, that tracks the effectiveness of that media channel. I have another one that tracks how that media channel interacts with this other one. And you just have these parameters specified, how they interact with each other, and then how they relate to the outputs, right? That's how the generative process works, from like unobservable causes down to data. So you write that out like you would a Python program that generates data, right? You just have individual nodes in that graph that interact and generate the data. And once you have coded that, then you just hit that, what I like to call the inference button, which runs that estimation algorithm, no matter what model you threw at it, and then you get the answers. So that for me is really the superpower of Bayesian modeling these days, is that we have really powerful tools that automate this whole workflow and make it very iterative, so that we can go in, build a model, a very simple model, see where it's lacking, improve it, just like writing a program, right? You start simple and you improve it. So now we can have that very powerful workflow just applied to statistical modeling.